Hello everyone. Now we look at lab 6, that is the week 7, the lab exercise, right? So we look at the lab exercise. So in this week, we're going to add sprite on our animation game, right? So what is sprite? Sprite in the context of computer games is a visual object, usually 2D, right? Sometimes most of them are movable, some may be stable on the screen, represent a user character or enemy or some bonus the stuff there, right? Okay, we're going to implement this sprite on our system. So we design this is focused on UI part. Yet this week, the later we try to connect with the data model. So this time only focus on AI part, UI part. So we create a sprite interface because we want something very flexible, starting from the interface most abstract. They only need to have two methods. The first method is node, get node. We use JavaFX, so the node is the basic items can be displayed on the screen. But what exactly is implementation is we don't know. But the abstract form is node, get node from this sprite, and also set XY, right? To set the location of the sprite. Okay, so that's two interface. And then we need to have a star sprite, so that is concrete implementation of this one. So this one is going to show a star on the screen. Look, the interesting part, a star sprite, even though it is a UI component, but itself is not directly component. It contains a star, which is the UI component. It's a node, actually from polygon that can be drawable, right? So this wrap, that's star. And also we need to have a sprite factory that's going to create various different type of sprite. So we use a sprite factory to make the creation of the sprite more controllable, right? Rather than hard code which sprite we want to create, we use a sprite factory to dynamically generate a sprite. And also we want this factory to be singleton. The reason is we don't need to have uh, many different instances of factory. One factory is enough for our game, right? Okay, so in this uh, class we have create sprite type, type location, right? So they are overloading each other. So actually, eventually the create one is from here, but all the others going to call method from here. So this just simplify the client side. They create a sprite. They can create a sprite without tell the factory what type they are, where is location, right? Let the factory to make the decision. Okay. Eventually, we want to update our UI. Therefore, we have UI here. We have the stars here. Okay. But of course, if look at only this function, why we need to bother to have so many different classes, make the such complex design. So if only for this purpose, probably the design looks too over complex. But if you continue the development, if you want to add more features, more functions there, you will realize this kind of design makes the extension of the game much more flexible. Right? Gradually, we understand the benefit of using this kind of design approach. And the last task, the second task is to draw a UML class diagram to show the relationship between all these classes, right? And the sprite, star sprite, factory type, and game paint, so on. The next one is to improve the ball control, right? So we're going to see what it means. Make it control the movement of the ball more efficient, right? Okay, so now we look at the code section. Okay. Okay, now is it the branch 5, so that's the last week's implementation. We have a quick look, see what we have achieved in last week. So in last week, when we start here, it's just a ball here. We control the goal. So see the speed, but we can see the control of the movement is not so easy by the direction, right? So, but that's one we consider next. But look at the screen; they only have the ball here. What we want is in the new implementation, we're going to have the stars here, right? Back, exit. Okay, so because of the real implementation take much longer time, so I'm not going to show the step-by-step how to make the coding. I just directly show the final result and explain the code, right? That's probably quicker. So this is still the last week's version. So we git switch F6 F6 switch. Okay. Now we look here, right? So we see we have created new folder, sprite. So we have all these new classes here, right? And also for the other part, there's not much change. Only game pane has some change. If you want to see what kind of change we have made, you can go to the website, come to here, right? So that's my GitHub repository, and then once you come to right, okay. So once you go to here to compare the lab 5, 6, right, complete lab 6 feature, and you compare with the previous version, you can see there all the new. This is something changing in the game controller part, right? Okay, here's some change in the game, but not much. And here's some change in the game pane, right? So later on we're going to explain the change in there in the code, but here you can see the comparison between this one and the previous version, right? So to do that, you see there's the base. You can compare lab 6 feature. You can compare this with previous one, right? Compare with the current one, and here they show the difference. Now we look at the new design, right? New design, and firstly we just quickly to run it, see what happened, right? Run this lab 6. Okay, so this lab 6. Click here. See, we have some stars here, right? And also look at the control of this ball become more controllable, right? If we want to move, touch this star, it's also easy to control, right? So let's change the logic. Okay. Now we look at the code. So for the new part, we start from the sprite. So sprite is interface. They only have two methods: node, get node, right? Void set location, set xy. And then we look at the sprite type. Start from simple one. This enumerate. So at this stage, we only have one type called star, right? Later we can add more. And also we can add something like decorator design pattern. We try to see how to use decorator design pattern and add like star with the time, star, moving star, stuff like that to create something more from this part. So far only one type. And for this type, they have concrete implementation. So this star sprite implement sprite, right? So implement that. If you implement that, you must override all the abstract methods. So the get node will return a star, right? So here we have a private attribute star, which node, right? Okay, get node, return that one, set x, y with star set, translate x, translate y. So this just means to move this object to this location, right, to this location. And look at what is the star. So star, we starting from this public um, constructor, star sprite, star equals new star, right? So we just use create another class to create instance of the node for this star. Okay, now we look at the star. So this is the real star one. So this star is, of course, it's a must subclass of node, right? It's displayable. So actually we extend polygon. Polygon is something between above the node. Node is the most abstract displayable things for the JavaFX. Polygon is one of the subclass. So star extend that. And look at the constructor. Okay, so the constructor, we have a default constructor, right? And then the overloading, we call this outer radius, inner radius, and name point. So this actually is, this star can be more flexible. It can draw the star of different size and also the star with different number of points, right? So by default it's 5, and by default we put the outer radius, so that because when we look at star is just let me maybe okay, you look at the star, it actually have two circles. The one is outer circle and the another one is inner circle, right? So the default size is outer one is 10, inner one is 5. So if you call default one, they give you this default value. Otherwise, you can call a star with other values, right? Make it larger or more point, that's fine. And this also need to call the super, so that is the constructor of the polygon, right? That double. So this is just the purely mathematical calculation, because when you draw a star, it actually draw a polygon with all this point, right? So this number of point 5, not number of 5 times 2, because if you draw a star with 5 points, actually they have, you see, they have 10 edges, 10 points, right? So yes, just create the 10 point and put all the 10 point to add to here, right? So because for the polygon they have get points, add here, add all the points, they're going to draw this one. And after that we fill the color with gold and set the edge is orange, so that create the beautiful star. You see that the design is try to make each class as pure as possible. For this star class, the function is just try to create a star, right? Just create a star, nothing else, right? Nothing else. And when you look at the star sprite, so that is the for the gamepad need to manage the sprite. Here they get this so where it is, and then the drawing become automatic, right? You don't need to worry how to draw them, and set x, so how to change the location of them, nothing else, right? So make this as simple as possible. Now we look at the sprite factory. So this one, so all the sprite should be created through the sprite factory, right? Okay, so from the sprite factory, right, because we want it to be a singleton, so that means this class can only have one instance. Therefore, we have a private constructor. So that means the other class is impossible to create instance of this one, because this constructor is private. Okay, even though there's nothing here, now I can create that. And then we use the build parks implementation for singleton, right? So they create internal class, inner class, and also this the static class, right? So that means this class can have instance without instance for the parent class, right? The private static is also private, so that this inner class only be accessible within this factory. They're not going to be used by other part class singleton factory, right? Singleton factory. So here with private static final sprite factory equals here, right? So this, in our lecture, we have already discussed this way to implement singleton is very effective, so that it's lazy. That means if you not call this factory, you're not going to create this instance, right? And also it's thread safe, so it's probably one of the best way to implement a singleton design pattern. Okay, once we want to get factory, because if we want to get instance of here, we just get factory to this public static. We return a singleton factory dot factory, right? Return factory dot factory. I can return this one. Okay, this must be static and final, and there's no other instance, right? So that guarantees one instance for this for this class. All right, so now we look at create sprite. Right? We probably start from the most basic one, the create sprite. Right? We want to create, so this is easy. So the caller want to create a sprite, they're going to return a sprite, right? So this, because it doesn't say what's the type, therefore we need to find the sprite type. Sprite type equals get random types, right? If the client doesn't mention what type is, we just randomly get one. So for the get random types, we use values equals sprite type. So that's the enumerate, right? Enumerate values, get all the values from here, and we put index equals random next integer, right? So the length, of course, in current case, the length is 1, right? So get next integer that return an integer less than this number, less than 1, because there's only one possibility, always 0, right? Return 0. But if you have more values, they're going to have one random type from here, right? So that's fine. Okay, so get random type, and we create sprite with type, right? Now we look at this function, create sprite with type. Now we know we have a type, but we don't know where this sprite should be, right? We don't know the location, therefore we just create random location. And x equals random next integer, we use the size, make sure this the x is within the game field, right? Or y is also within the game field. Okay, because this is double, we need to cast it to integer. They need to use and this narrowing, right? Needs to use this explicit casting. Okay, and here is integer, right? And then we assign integer to double. This also cast, but this implicit cast, we don't need to say this is a double, because it's automatically cast from integer to a double, right? Now we call the function create sprite type xy. Now we come here. So that's a real function to create sprite, right? Create sprite type. Now here we use enhanced switch expression. The sprite equals switch types. So case star we new star sprite, right? If we have other types, we're probably going to create other way differently, right? So we're going to see what happened. But now it's only this one, and then we have the sprite, we set xy and return xy, right? So that's the function for them. So that eventually we have a whole bunch of here, and the client, like the game, want to have sprite, they just call the factory to create sprite, right? Now we come to look at the game pane, so how it achieve that. For the game pane, now we define a list of sprites. So that means for the game pane, originally they only have the ball here, right? And the game is the data of game ball. That's the one moving around. Now we have the sprite. So of course, later on you may consider the ball can be considered as a special sprite as well. Later on we're probably going to move this ball be managed by sprite as well, right? But at this stage they are not combined yet. So we have ball, we have the sprite here, the finalist sprite here, and then we need to initialize this sprite in the game pane, right? It's constructor sprite equals new array list, right? Array list. So the list is in interface, the array list implementation, array list of the sprite. Okay, then we look the other part that game has nothing changed. You look here, when the game animation, it doesn't really doing anything about sprite yet, right? Look here, not related to the sprite. So later on, we're going to see how to let the sprite interact with others, like part of the game, but not at this stage yet. We look at this one is initial sprite, right? Initial build game pane. So this one is actually to build all the element on the pane, right? This part is as before. We have a few stroke, and okay, here we have a clip. So this is something new this time, because look at this one. This one we have this star is drawing at the edge part of the display area, right? So we use the clip, means we don't want the star to be drawn beyond this boundary. Okay, so the clip is actually the boundary of your display, right? The boundary of your display. So we just do not to have them. So that's a new part. The clip, that's rectangle, the size, and also set clip to make it to be a clip. The circles here. So this part is the same as previous one, and here we have initial sprites, right? So we have the init sprites. Every time we want different, so every time we build the pane, we're going to have different set of sprite with initial sprite. So initial sprite, we look at this function sprite clear, so we just remove any sprite in the list because it may have sprite from the previous row. Clear them first, and then we for I equals number. So here is how many sprites we want to create. I put 10 there, right? So they run doing the for loop. So sprite equals sprite factory, get factory, right? The single pattern gets the only instance of the factory and create sprite. Here I just use the default method, so I don't care about the type. I don't care where the location. Just create, and then the create it we add to the sprites here, right? So in the build pane, we have initial pane sprites, create 10 of them, and for each sprite in this sprites, for each of them, we get children add the sprite. But be clear, we are not add the sprite because we need to add the node of the sprite, right? Sprite dot get node. Okay, so see here they have get children set all, right? Set, we have field, we have ball. Now we add all the sprite. Okay, so that is. So then you look here, you see all the star here, right? If you again, you see the star going to draw in the in a different location, right? Because randomly generated. Okay, so of course later on we're going to implement more features like the star can move around, our star can disappear, and then once if our ball click on the star, what happened, and maybe have different kind of the different kind of the surprise, right, to make the game more interesting, right? But this week we just come to here. And also you may look in this week, we apart from that, I also create something called game entity, right? So this is for the game part, we probably want to have also similar to the sprite. On the sprite is the UI concept, but it may relate to certain kind of entities in the game part. But this section is only create abstract class, not implemented yet. Later we're going to introduce it. Okay, so that's for the coding part. Now we look at the class diagram for what we have created so far, right? Okay, here you can see the class diagram. Okay, here you see the solution, the class diagram. Here I probably quickly explain that. So look at the class diagram. We have the sprite, so that's the central part of what we create, right? So sprite is part of the game pane, but game pane can contain one to many, right? So yes, so many of the sprite in the game pane. Okay, many and also all belong to here. And for this interface, we have one concrete class. Here is implement, right? So here, because it's interface, so that implements a dash line, right? And for the star sprite, it contains a star, right? So this is more solid. The reason is this once create this, they cannot destroy, always be here. But this one they can remove, clear, and create a new one. So that we use the aggregation. Here we use the composition, right? And for this star actually is extend from polygon, right? Polygon is a node, right? Extend from polygon. And also for the sprite, it can be created from a sprite factory, right? And here is a type which is different from what we have learned before. So in the previous study, in the previous lecture, we introduced there are three different types of relationship for the class diagram. Part of relationship, right? So there's aggregation or composition part of relationship, and also associations. So in this example, we don't have association, even though this can be considered as part of some of kind of association. We don't have association here, but we have inheritance, right? So these are two different kind of inheritance. So this is extend, this is implement, right? So that's three: relationship, association, aggregation, and inheritance, right? But here we use the fourth type. It's called dependency, right? So we can see they are not directly associated, but the game pane require the sprite factory to create sprite, right? Yes, the sprite creates through them, so this game pane depends on the sprite factory. You say there's a dependence. This is not the other way, because the sprite factory doesn't know the game pane, right? But game pane need to know the sprite factory, use the sprite factory to create sprite. Okay. And also for the sprite factory, it needs to know the sprite. Okay, need to know the sprite. So when you create sprite, going to return sprite, right? But of course, the concrete one here need to know this. And also the sprite factory needs to know the sprite type, right? What type of sprite. So this is some kind of relationship not included in the early version of UML diagram. In the later UML diagram, they introduced this one, but this is a weaker relationship. You can include them in your design, but you can remove them if design become too complex. But in our case, because we only show these classes, and then it's not too complex, so we can include this kind of dependence relationship. This also gives you an example of class diagram with size of this connection. It's easy to read and also help you understand the design, the relationship of the classes in this situation. Do not make your class diagram too complex, too hard to read, right? I don't, in this example, I don't need to draw the different screens, game, and so on, because I'm only focus on the sprite and also how they relate to the game pane, right? So I only need to draw this diagram. And also you look at the attribute and the method. I don't include all of them. I only pick up something I think most important, like initial sprites, sprite list. So this probably interesting related to this part. We show this here, right? And get nodes, this of course only two methods here, and this we show the get factory, create factory. I don't show the internal class because that's probably not interesting for the other part, only interested by itself, right? So I don't include the polygon attribute and the method because they are not so important. This part purely independent of the other part, only try to create a solid displayable node, right? Then eventually just a node. Okay, so that is for the class diagram, and also explain how you draw class diagram and what kind of things expect you to include in the class diagram. Okay, so before the end of this week's help for the lab, we probably have a quick look of this week's quizzes, right? Quizzes for, oh, sorry, I forgot to switch to, yes, I probably need to switch to student view, right? Student, and look at the lab quizzes. Okay, and begin. Okay, Crystal. So fill in the blank. The value of result. Result square apply as int, right? Okay. Let me see. The int unary operator. Okay. In the unary operator, x equals x times x, right? So the result as square as apply as, so that should be 16, right? 4 times 4. Okay. Function, so this function from a string to integer, right? So it's called length. So s to s length, hello, 1, 2, 3, 4, 5. So the length should be 5. Which of the function interface return Boolean values, right? Predict, right? Supplier is don't only supply something, consumer something, function here and return this, but this one is the function interface, right? Functional interface. Okay, function here usually it's one abstract type and another type rather than just say t boolean. No, not this way. Okay, so this predict. Which of the following is the true about static nest class? Static nest class, it can access only static members of the outer class. It requires an instance for the outer. It's true. It requires an instance of the outer class to be in because static, so this is definitely not true, right? It can be defined only inside method. No, it's implicitly abstract. Not really. It can access only static members of the outer class. Yes, because it's a static next class, right? Which pattern is designed to dynamically wrap object and new behavior without changing their classes? It's rather designed to dynamically wrap object to add new behavior without changing their classes. Okay, that is decorator, right? Dynamically wrap objects to add new behavior without changing. Decorate or composite. It is designed to dynamically wrap objects to add new behavior without object. Yes, I think it should be decorator. Even though the conversation looks also close. In the state logic display pattern, what is the main of the logic, right? The main sensor store, understand the state based on input to render the user interface. No, that's for display. To update the state based on input output. Yes, so that is for logic, right? Store static interface, no, to maintain set. Where can a local inner class be defined? Local inner inside a method of our constructor? Yes, in a separate source file now, outside of our members, inside the static block. Okay, no, only local inner class inside a method or constructor. Okay, look this one. Main supply double, so let's supply something. Supply here, and it's going to supply 42, right? Okay, double result get. Okay, random supply. So the supply 17. This actually supply 42, right? So it's 42. Okay, so because look here is a double, right? Double. So therefore, even though it's an integer, when it's double, you need to add dot 0. Otherwise, they will give you error, right? Okay, which pattern enable behavior to attach to object dynamically without affecting the other object of same class? Yes, it's decorator, right? Which pattern enable behavior to be added to an object dynamically without affecting other object of the same class? Yes, this is private. No, not this one. Which of the following is true about singleton pattern? It's only one instance of classes is applied global access. Yes, that's true. Creating multiple instances, enforced inheritance. No. What does grasp principle indirect promote? Right? Or also place intermediate object to reduce conflict between component. Yes, indirect access object directly. For performance, no. Use global variable. No. Okay, and how many questions? Oh, still a few. Create a database gateway class solely to handle persistence is example of pure fabrication, right? Create class solely to handle persistency. Yes, make this persistency rather than part of it. That's purely fabrication. Yes. And which of the following grasp principle would mostly encourage use of facade? Pure fabrication? No. Polymorphism? No. Protected variation? Indirect? Yes, that's probably this indirect. So that insert a layer between the provider and the client, right? That's indirect. Yes. And Look, this one creates, okay, the list of word, the list of 3 words total for this total equals length, right? Okay, so that's easy. So just the total of the length, right? 2, 3, 4, 5, 6, 7, 8, 9, right? So it's 9. It's 9. Next one, main printer set amount print, right? Okay, so this just call it with the consumer because it's going to take something here, right? Consume something, take a string, right? Print accept hello, right? Okay, and the value printed to the console is hello, right? Okay, right? Because it take this accept this hello. Oh, still one more or 2 more. Which of the following is the valid lambda expression that take no argument and return nothing? Okay. Lambda expression that that take no argument and return nothing, right? Which is valid, definitely not this one. Let's take an integer, right? And also, okay, this is for JavaScript error function, and here this take nothing and return nothing, right? Okay, so this is a lambda expression. Yes, so this one, lambda expression. In SRD architecture, so that is that's the state logic display, right? Which component would be responsible for stimulate input rules, right? Which component would be responsible to stimulate input rules? Okay, the sensor, right? So this input rules to simulation, respond to simulation input rules. Yes, the sensor, not logic. State. Okay, let's see. Hopefully, do not get something wrong. But right, there is one wrong. Okay, this one. I think it's probably the composite. Oh, this one is wrong. Which component would be responsible for responding? Responding. Sorry, I didn't read that clearly. Responsible for responding to simulation input rule, right? Okay, so this responding to input rule, so it should be logic. Yes, should be logic. And we have a quick check before the one we are not 100% sure is the decorator correctly in the class update state facade decorator, right? Designed to dynamically wrap object. Yes, so because decorator, we have something we can use decorator to wrap it, and after wrap it, it still belong to the same kind of classes, even though the implementation may be changed, but yes, so this is decorator. All right, sorry for this mistake, but when I read the question, I missed this one. Responsible for responding. Yeah, responsible for responding. Responding. So that means this is not input, responding to the input. So that is logic, right? Responding to the input. All right, so that's all for this week's lab solutions. Hopefully, it's helpful. Okay, so see you next time. Bye bye. Thank you for watching.